We're back on the Pete and Judy business, and we get the mean of C. That's how much Pete is pulling in per day, and the mean of G. That's how much Judy's pulling in a day. What they're asking us to do is, hey, find the difference and calculate the new expected value, the new standard deviation and variance. Well, with the mean, um, we're looking for the new mean here. And that's going to be real easy because we're going to go ahead and just subtract them. So 562.50 minus 542.50. And our new mean is $20. That means on average Pete collects $20 more than Judy on a given day. But remember, this is the mean. So on some days it could be Judy collects more. On some days Judy collects less than this. It just depends. But the expected value is Pete is expected to collect $20 more than Judy. The next thing they want you to do is we want a new standard deviation. From our rules, since these are independent, we could go ahead and plug them in our equations. And if you were to go ahead and calculate that out, that's $53,954.07. So that is the variance to get the standard deviation. You need to take the square root. And what that is $232.28. And what that is saying, that on typically, so the difference in amounts collected by Pete and Aaron is $232.28. So the average difference collected is $20, but the difference on individual days is typically $232. Let's take a look at a T problem. What they say is, hey, we want 8.5 to 9 grams of sugar in a cup of tea, and that's going to be the perfect cup of tea. So you got to add tea packets, and if one tea packet, so like packet 1, the mean of packet 1 is 2.17 with a standard deviation of 0.08. So what it says is he randomly selects four packets of sugar. What's the probability this tastes right? So what we need to do is we actually need to go ahead and add up all these packets of sugar. Because this is packet 1 packet 2, packet 3, and packet 4. And if we go ahead and do that, we get 8.68. But we also need to go ahead and then find the excuse me, the mean and standard deviation and variance. So from our equation, we have to do these 4 packets. Remember, you can't just add standard deviations. What you need to do is we have to go ahead and do it by the variance. And if our standard deviation is 0.08 squared plus 0.08 squared, and if you do that, it's 0.0256. So that is our variance. To go ahead and get standard deviation, take the square root, and our square root of that is 0.16. So this is what we're dealing with right now. And we need to know is, hey, it needs to be in between 8.5 and 9. So what I'm going to do is actually draw my normal curve, because since one packet's normal and we're adding, whenever you add things together, it's still going to be normal. If you have 4 packets of normal, you add 4, normal curve stays normal. So we're wondering where it's in between 8.5 and 9, and 9 is probably going to be way out here. So what we are looking is we're looking for anything that is in that range. So what we need to do is go ahead and find a z-score. And then what we need to do is turn those z-scores into a probability. The z-score, or the probability of a z-score of 2 is 0.9772, and the z-score of negative 1.13. And since I want the area in between that, what I could go ahead and do is subtract them. So what I get is I get a 0.8480, so that's like an 84.8% chance that the tea actually tastes right.